In the present video, I'm going to demonstrate some elementary algebraic manipulation of expressions in Maxima. If you open the, sorry, this is not supposed to be there. If you open the Maxima documentation file available under the start menu for Maxima, you're going to find a PDF file that has 1,236 pages. And there's information here about data types and structures, expression, operators, evaluation. Very technical from a point of view, from a programmer or computer science point of view. For example, you took expressions, and it shows you a bunch of commands that you can use, and it talks about nouns and verbs and so on. But the good people that created Maxima have provided us with some menus here that will help us navigate through all that information and provide the most commonly used commands. For algebraic manipulation, the simplify menu is the one that we want to use. So you can see the simplify menu has three parts. This part that ends right here. Then there is this part in the middle that has several sub commands. And then you have this one, this last part. So I've tried to make my videos relatively short, and so it's not going to be possible to cover all that in one video. So we'll start with this first part here. We're going to talk about the first set of commands. Now we have a freshly newly created interface in Maxima, which is great. And now we're going to show you what happens if you go to simplify and click, or yes, click on the first command here. It says rat simp, and it gives you a percentage. Now, by default, the argument is going to be the percentage, which, remember, it means the most immediate result. There is no most immediate result, so you get back this. And here's where you're going to put your expression that you want to simplify. Now, the rat simp command has a funny name, but all it means is rational. I'm going to enter here a Maxima. Sorry, in the cells, a text cell. Rat simp means rational simplification, and it refers to algebraic manipulation. So if I now click to the right of the percentage and press backspace or delete, and then type an expression, typically a multiplication, like let's say x minus y, right arrow, times x minus 5 times y plus y cubed, for example. And it already provides for me the semicolon. So now I do shift enter, and I got that thing simplified. It can be used to simplify fractions too. For example, if I say simplify expression, and now it refers to the last result, but I want to delete that, and I'm going to type, say, x cubed minus y cubed. Now I'm missing a parenthesis there, so I'm going to click to the left, open the parenthesis there. But when you open a parenthesis, it gives you the closing parenthesis. So what you want to do is click to the right of that parenthesis, delete. Now click to the right of the cube, close the parenthesis, and then say time, I am back to the right. I'm going to go back inside using the arrow, times, oh no, it's not working. Let's try right there. And so now I have another parenthesis. I'm going to delete. I should have done a fraction line, and then the open parenthesis in the denominator, I'm going to say x minus y. And then I do shift enter. And what it did, it actually expanded or factored the x cubed minus y cubed. So what it did is it simplified my fraction. Now, if you type that fraction just like x cubed minus y cubed, right arrow divided by x minus y, shift enter, it just types the expression like as it is. It did not rationalize. But if I go now and say simplify expression, it gives me my rational simplification as I obtain over here. So that's the first command on simplify. Then the next command is simplify radicals. And of course it tries to apply to the previous one. And so it's kind of like difficult to come up with a example for that. So I have an SMAS Studio file that I keep keeping notes on that. And here's the first 7 menu options under the simplify menu. And so I'm going to use the simplify radicals by simplifying this quantity. So I'm going to copy this as a text file, Control C. I'm going to go to my Maxima file, insert or put the insertion over here and do Control V, and then do Shift Enter. So I have an expression that's the square root of x squared plus the square root of the square root of x squared plus 1 divided by square root minus 1. And so you have square root of square root is the power to the 1/4 and so on. If I now go here and if I do Shift Enter, it actually is referring to the last result, which is this one. But all what it did is just separate the denominator into the square root of x minus 1 and x plus 1. So this is kind of a type of simplification that's kind of difficult to come up with an example. So we're going to skip that one. The next one is factor expression. And so it's trying to refer to the previous one, and it's already factored out, so there's nothing to factor. But I do have an example here, and that's factor x cubed minus y cubed. I'm going to do Control C here and go back to my Maxima, do Control V. So that's related to this example right here. Factor this, I click on that and do Shift Enter, and it gives me that factorization. Now that factorization is what was used in here, right? So if you do the rat simp, I'm going to type the command here, rat simp of this quantity. I'm just going to copy that quantity. Actually, I'm going to erase this, and I'm just going to type that quantity. Control V, divided by x minus y is what I had over there in the earlier example, and do Shift Enter, and it actually gave me the simplification. I was trying to type this and leave it there and then use the rat simp, but it wasn't necessary. So I'm going to skip that part. I'm going to go back to my SMAS Studio Notes and try this command called gfactor. Now the gfactor command is the next one in simplify, and that replaces to factor complex. That's factoring with using complex number. For example, the quantity x squared plus 4. Now that in real numbers cannot be factored out, but using complex numbers, if you do Shift Enter, it's factored out in x minus 2i times x plus 2i. And so that's what the use for that is to factor out using complex numbers. The next example has to do with an expansion, and I'm just going to copy, well, I'm going to copy the argument. Control C, go to Maxima, and then go to simplify, expand expression. It's asking me to expand or it did the expansion of the previous result, but I'm going to delete that and do Control V, and click on it and do Shift Enter, and it's expanding that product. Just for the heck of it, I'm going to type factor, parenthesis, percentage, Shift Enter, and I get back to this expression here, except for the change in sign that Maxima does kind of arbitrarily. Next one is simplify, expand logarithms. Now that's an interesting command because it requires you to have an expression earlier on. So I'm going to show you how to do it. If you have this expression, by the way, in SMAS Studio, which is this file, the function ln is the natural logarithm, but it doesn't work in Maxima. In Maxima, there's no ln. If you type ln of 5, shift enter, you get ln of 5. That's like an undefined function. Instead, the function is called log, simply log, like that. Well, let me try something here. If I type ln of 5, and I'm going to go to the right and say semicolon, and then I'm going to do float. Float is convert to floating point number. So let me see if it will actually give me a result. So I do shift enter, and it doesn't give me a result. But if I try it in here, and I try float, and do shift enter, it does give me a number, which means that the function log stands for natural log, which is the same result that you get if you use ln of 5 in SMAS Studio. All right, so something to keep in mind. In here, I'm going to type the example that I have here, which is this log. And type shift enter. And then I'm going to use this command, which comes from simplify, expand logarithms. So it's saying, okay, take the last result and use this option, log expand equals super, and it converts this logarithmic expression into the sum and subtraction logarithms, following the rules of multiplication of logarithms. Finally, for the last command, it's contract logarithms. It refers to the last result, and it basically return this expanded version into the contracted version as shown in here. Let me see if I have an example related to that. Yeah, I do have another example, so I'm going to just copy this log contract back to Maxima, Control V, and Shift Enter. And so it produced that log contraction. With that, I wanted to cover the first part of the list of simplify menu for algebraic manipulation, and with that we end up this particular video that I'm going to call part 1.